Decomposition of functions. So we've talked about composition of functions. That was where we plugged one function into another function. Maybe I'll come back over here. This is the previous video. This was us plugging one function into another function. So here we're plugging function g into the function f. Just a bunch of algebra. But this was combining two functions together. Now I want you to pay close attention. Oh, well, there's my son doing math. How adorable. Give me a sec. Okay, there we go. This is the difference quotient notes. Here we go. I want you to pay close attention to what things look at this step right here, when we've composed but we haven't simplified. So note the function f looks like this, x squared plus 1. When we plugged g into him, it turned from x squared plus 1 into 2x minus 3 squared plus 1. Over here, the function g is 2x minus 3. So at this step right here, instead of 2x minus 3, it was 2 times x squared plus 1 minus 3. Right. This step here, same idea. Take a look at what it looks like before we've simplified things down. When we're talking about going this opposite direction, we're kind of looking at finding like an inside and an outside function. So if I look at this function right here, this is the function 2x minus 5 quantity cubed. If I can think of this in steps, I can think of how I could backwards engineer a composition that ends up this way. I know I'm starting with 2x minus 5, and then I'm cubing it. That's what h of x does, right? H of x starts with 2x minus 5, then cubes it. It's really like you're plugging 2x minus 5 into a cubic function. So if I look at the 2x minus 5 as being the inside, and I look at the outside portion, which I'm going to write as box cubed as the outside, cubing something, right? Cubing whatever's in the middle. Let's call that x cubed. The outside function is x cubed. I'm just ignoring what's in the middle. The inside function is 2x minus 5. I could see this function as being a composition of these two functions here. So if I said that f of x was 2x minus 5, if I said that g of x was x cubed, then h of x is the same thing as plugging f into g. So that would be g composed with f. To prove it, f of x is 2x minus 5. Now I'm plugging 2x minus 5 into the function g, which is x cubed. So that's 2x minus 5 cubed. Okay. We have our inside function and our outside function. This is a topic that comes up a lot in calculus. You'll do something called the chain rule, and the chain rule relies on you being able to identify these inside and outside functions fairly easily. That's why we talk about decomposition of functions. We talk about it because it's going to come back up again in calculus. The outside function, remember, should be the one on the outside of the composition, and the inside function is the one on the inside of the composition. So you might see a problem like this. Suppose you have this function, h of x is equal to the square root of 6 minus 7x. Find two functions, f and g, such that f composed with g is equal to h of x. So here, well, let me rewrite it. This is the same thing as f of g of, I forgot to put an x here. There should be an x there. Oops. F of g of x is equal to h of x is what this says. So g is my inside function. F is my outside function. My outside function is going to be f of x. Looking at this function here, on the very outside of this function, we have a square root of stuff. Right? We're taking the square root of 6 minus 7x. So this outside function is really just the square root portion of it. It's going to be the square root of x. It's like thinking about it as the square root of stuff. But instead of stuff, we put x. For the inside function, that's just whatever's inside here. So 6 minus 7x. That's on the inside of the function. So if we compose these, if we do f of g of x, g of x is 6 minus 7x. So plugging 6 minus 7x into the function square root of x, I get the square root of 6 minus 7x, which is exactly what h of x was. So really, you're just kind of looking for like a base function on the outside, right? In the case where we had everything cubed, that function on the outside was x cubed. In the case where we were taking a square root, that function on the outside is that square root. And then whatever's on the inside becomes that inside function. So these would be the answers right over here. There are the two functions. There's f, there's g. Those are what the functions need to be in order for the composition to come out this way. Anyway, that's decomposing functions. It's not really a huge topic right now for us, but it is an important one. So I hope that helps. If you have questions, let me know. Otherwise, quick video, done.